Hello, I am trying to go live. Why isn't this working? Oh, main, okay, that's what you're doing, okay. Alright, so this is a commonly given Facebook problem. I'm starting it at 6:43 p.m. Let's see. So I'm given a file, and I can only read from the file using Read4, which reads 4 consecutive characters from the file. So basically, this assumes, well, there might not be 4 consecutive characters from the file. There might not be 4 characters remaining from the file. So then writes those characters into a buffer. So it takes in, okay, so I have to provide a buffer, and it returns the number of characters read. Got it. So it's a source. This is a destination, not a source. Okay, I got it. Okay, I'm looking through the example. On the final read here, Read4 returns 0, which means there are no more characters remaining in the file. Okay, so here is an example. Initially, the file pointer points to A. We create a buffer with enough space to hold 4 characters. The first read returns 4 because there are 4 characters. The second read returns 1 because there's only 1 character left. And the final call to read returns 0 because there are no more characters remaining. So I have to implement a method read, that's this one right here, that reads n characters from the file and stores it in the buffer array buff, which is something that's been given to me. Cool. So the return value is the number of actual characters read. Okay. So n is the size of the buffer, I think. Oh, okay, no, it attempts to read n characters. There might not be n characters. So, got it. Okay, let's see. There are 4 examples here. So how do let me think about this. So basically, I've got a buffer. Let's take this as an example. So I've got a buffer of size 4. I'll just work with the first example. Buff is equal to, and there are 4. This is the current insertion point right here. So then I'm going to call, and the file is actually this. So this is the current position in the file, the current file pointer, that is. And so I call, so n is equal to 4. Okay, let's see. So in the first call to Read4, basically I would write I guess I would have a temporary buffer. Let's see. Of size 4. I would, on this call, the temporary buffer would until it would return 3, and write A, B, and C into the temporary buffer. So let me just review what Read4 takes in. Read4 takes in just a buffer, so I have to provide a temporary buffer. And then I sort of subtract. So I set, let's have a variable with remaining, with the remaining number of characters left to read. So here's 3. So after this call, there's 1 remaining character left to read, but since this did not return 4, we know there are no more remaining characters. So actually we write everything from here and here into the buffer. At this insertion point, we increment I forward to just past the written characters. And then well, one issue is maybe we read too many characters, which I will handle that in a later example. So in this case though, 3 is returned, and we're simply able to write the contents of the buffer, of the temporary buffer, into buff at the insertion point. Let me construct an example in which Read4 reads too many characters. So let's say the file is like this: ABCD, ABCD, and also, or EFGHI, H and IJKL. Well, we only want to read, let's say, 6 characters. So actually n is equal to 6. So n is 6 and remaining starts off as 6. So we initialize remaining to n. So we've got the buffer, it's of size 6. We've got 1, 2, 3, 4, 5, 6. N just stands for none. The insertion point is here. So we have a temporary buffer. This. Temporary buffer, so we call Read4 one time. So this populates the temporary buffer with ABCD, like this, and returns 4. And we subtract 4 from remaining, so there's 2 left to read. We write the contents of the buffer, of the temporary buffer, into the return buffer, and we move I all the way up here. Then we call Read4 again, and basically what happens is we get to these next 4 characters, like that. So Read4 also returns 4, but we only need 2. So I guess when we copy, we take sort of, for the length, we take whichever is greater, the remaining number of characters or 4. So this returns 4. So we're going to take these and basically copy them here like this. I guess the insertion point, well, okay, so we'll yeah, I guess we can just discard this stuff. So we'll just take the remaining 2, and then be done with it. We push I past the end of the buffer, and we're done. So that I think that works. This approach works for that case. Let me try a different example. One in which the buffer is too big for what we need it for. Let's say the buffer is of size 6. Like that. But the file is only, say, 5 characters. So 6 here, remaining starts off as 6. Buffer is initially empty. This. So we make one call to read4. We fill in the buffer. With these characters right here, A, B, C, and D. And we return 4. So 4 is smaller than 6, so we copy these 4 things here. A, B, C, D. We had the insertion point and we move it up here. Then we call, then we subtract 4 from remaining, which is 2. Then we call read4 again, and basically this will initialize this again, or we could just use the same buffer. It doesn't matter. So basically, there's the file pointer is pointing here to E. So E is written here into our temporary buffer. Read4 returns 1. 1 is smaller than 2, so we write E here. And since we see that 1 is smaller than 2, we know that we don't need to continue. We just push I past to the first character, first slot that's not populated, and then we just go ahead and return I. So I think those are all the cases. I'll check the boundary solutions at the end, such as when there's an empty buffer. Case, empty buffer. But first let me get the normal case working. This case is pretty good. I'll get this one working. So let me just move this closer to my code. That. So obviously, we're going to start here. And remaining is initially 6. Buffer is initially of size 6, like this. This is the insertion point. So insertion point is 0. The buffer, I will assume, is big enough. It's a n of size n. I'm going to have a buffer of size 4. I'll call it buff4, actually. Done for in range 4. That. So I've got my buffer. And I think that's good enough to start. So basically, while, oh, I forgot to initialize remaining. So remaining is initially n. While remaining is larger than 0, we're going to actually call read4 into buff4 like this. I think that's how it works. Let me just double check. Right, so basically now TMP holds A, B, C, D, E. This. or characters read rather. Let's call it num read. And the insertion point is currently 4. So I'm going to write to this buffer at the insertion point. So buff insertion point, and for the length, I'll take the smaller of the two, remaining or 4. That, or remaining or num read rather. Is equal to buff 4, and it's just going to be, I'm going to take num read characters from buff 4. So I think that should work. I will also break if num read is I want to say less than remaining, but that feels wrong. So let me just write that down and look at it. No, I think that's fine. So let's say it reads 3. That means there's no more. Okay, so if num read is less than 4, then there's no more. I can just break. Even if there are remaining parts. But I do want to increment the insertion point. So let me just have a num written. So it's gonna be like this. Or num. Yeah, okay. I got this botched. Okay, num written. Because we might read more than is needed. So that's why we have to truncate it if we read 4 characters and only 2 were required. So we add this to, if we wrote 2 characters, then we move the insertion point 2 characters up. And if we read fewer than 4, we'll just break. But then we return the insertion point. Let's see what else. What happens if we read 0? The num written will be 0. And then this will be a no op. And we'll move the insertion point by 0. And we'll just break from the loop. So I think that should work. Let me just run it on the example. So it works on this one. So it let me test on this example right here. So that one too. Try this one. Like that. And let's try this one. Ooh, this one's wrong. Oh, there's something broken about, okay, I thought okay, maybe I should have tested this a bit more, but, yeah, I did go through this, but I guess I did not test it prior to running the code. It's okay, I didn't submit it anyway. So basically, I think this happens when we read in more than we want. So I thought I handled that in using this. So at the insertion point, I'm only writing remaining characters here. And I'm only grabbing what I need, not the whole buffer. Let me see. So I'm just going to run through this manually. So let's see. File is the code. File pointer is pointing to the L. Remaining starts off as 5. Insertion point. Here's a buffer. It's of size 5. 1, 2, 3, 4, 5. And this is the insertion point. That buff4. It's got 4 things in it. And so I call it Read4. This is going to return 4. It's going to fill this with L, E, E, T. And it's going to return 4. So basically num read is going to equal 4. Num written is going to be the smaller of 4 or 5. Oh, I see what I forgot to do. I did not decrement from remaining. So remaining like that. So that should do it. There we go. Let me think of other cases. Let me try when it's empty. So if it's empty, this will be 0. This will be 0. And this will be a no op. Nothing will happen here. And we'll break out of the loop here. So that should work. I think I've tested everything. What are other cases? Anyway, whatever. It's quite a slow. I guess my algorithm's quite slow. Anyway, that's the problem.